What's up, everybody? With me, as always, is Mr. Bill Skywatcher. How you doing, Bill?
Happy Good Monday. Hope you're having a good afternoon. The start of the
Happy Good Monday. Happy Good Monday.
Happy Good Monday.
I like it. I like it. Happy Good Monday.
It's the start of the week, so I mean, it started to go on a positive note to start the week off. So, and it's always
the
great.
First day back at work. Happy Good Monday.
And you get us on Monday. So
you poor people.
So what? Anything new on your end? I'm not hearing much new on my end about this upcoming hearing and stuff like this. It's pretty much the same thing. Just sitting and waiting.
Yeah, it sounds like Burchett basically said he doesn't want to let the names out too early this time, and he wants full disclosure. Well, I doubt that'll happen. Hopefully, they have some good stuff. And we have a guest that happens to be very well versed on one of the topics that will be coming up in those hearings. USOs.
And you spoke with Burchett, but somebody that is allegedly going to be speaking there is Rear Admiral retired from the Navy, Gallaudet. So Mark actually was in a film that Darcy did, Transmedium USO Fast Movers, that one. And Mark did I'm telling you, I've heard Mark's account numerous times, but it was so in depth what he discussed about his USO experience on a submarine, a nuclear submarine, and we'll touch on that. But Mark, I mean, I love Mark. I respect Mark because of the science, the data, the search for evidence. Mark, he does the photo analysis for MUFON, and it cannot be easy for him at times when he's got something coming across his desk and he has the logical, rational explanation. And sometimes people don't like to hear the truth behind it because they want it to be, it's a UFO. But that Mark is he takes that approach, boots on the ground. He does the research. And like I said, he's a friend of ours, but I admire him for what he does and what he does on Sky Tour, live stream on his streams.
He's a man of honor. He would not steal the last piece of chicken.
And also Sky Tour that he airs on KGRADB.com on Sundays. So without any further ado, let's just bring him on.
Happy afternoon, good. Merry happy?
I just finished doing Christmas lights, so I'm in that weird festive mood right now. Everybody thinks
Christmas lights for Halloween. Nice.
It's Toby. It's Bill. I'm like under both of them. I'm like being crushed. Okay, what's going on, guys?
Nothing much, but we'll talk about Crush more as far as.
You better be doing something much. This is a show. You gotta have stuff. Go. Move.
A happy Good Monday.
Happy Monday. Happy good.
You want to start it off, Toby? Because I'm ready to get to this craziness that we've been hearing about for the last few weeks. Actually,
we can just dive right in.
Just dive right in.
A lot of rumors going around right now about Congress people being briefed on the James Webb telescope spotting something that is about 10 light years away, headed towards Earth. Obviously, you're an astronomer, so you'll have a take on this. We'd love to get your opinion on the recent scuttlebutt going around.
The Armada.
Yeah.
The Armada.
Okay, well, first of all, the James Webb is really a spectacular instrument. We can talk about some of its real discoveries it's made. And as you can see, I'm already kind of going down the path saying that this supposed Armada self-correcting and heading toward us is completely unfounded, and it is. There's no data indicating it. There's no find that's actually happened. This is just people who want to get clicks on YouTube, okay? And so they're creating stories. There have been many stories like this over the years with every variety of spacecraft that's been out there. What did the astronauts see? What happened on the shuttle? What's that thing around the shuttle? What's on the ISS? What's that light outside the window? It's happened a lot, and I'm not jaded by it, but I'm realistic about it. And I do think they're here, however, and most of you know that. I do think that they're here. There's a way they could be here that actually requires a little more advancement than we have, but they could be here rather easily. and they could have been here for a long, long time. But the bottom line is, in the James Webb case, it hasn't found anything coming toward us. No, that's not true. Unequivocally false.
Mark, do you think a lot of this also is in connection with Oumuamua, when people were coming up with this conclusion?
They used the Oumuamua as an example. Is it another Oumuamua? Exactly. Messenger from afar, right? And as it turns out, no, they're just using that as a possibility because, hey, we had this big astrophysicist, and of course that's Avi Loeb, right? He said that this could be an extraterrestrial thing. Well, I know he was saying what people wanted to hear, but I know Avi, and I know him well, and I know that he wouldn't say things that he doesn't think are true. And so he has a theory, and his comment, for instance, was taken kind of out of context. He didn't say this was extraterrestrial, this was alien life, it's proof. He didn't say that. All he said was, we can't ignore the possibility that this might have been an extraterrestrial vehicle. We can't ignore the possibility. And he's right, we can't. And the reason goes well beyond people looking at all the many, many stars saying, well, why would they ever find us? Why would they look for us? And the answer is very simple, actually. And it's something I lecture on all over the world, actually. And it goes to this. We, as carbon-based beings, need oxygen to survive. Oxygen provides us with the energy and allows us to regenerate our tissues and allows us to actually function and metabolize food. All right. It's all something that carbon-based beings require. So therefore, if you're an alien race on the planet, say 5,000 light years away, and you're a carbon-based being, you're also going to use oxygen undoubtedly. Oxygen is the third most abundant element in the entire universe. Third. Okay. Right. Carbon's fourth most abundant. So hydrogen and helium are the first two. Right. So obviously, there's a huge relationship between carbon and oxygen in the universe. So carbon-based life is probably a template in the universe because it's so common. Carbon can bond with more things and create more different compounds than any other element in the periodic table. And silicon is right below it, and that's the next most likely one that could do what carbon does, but it's not even close, right? So carbon is probably – I'm a carbon bigot, I admit. All right, I'm a bigot about carbon. Okay, happy to say that I believe carbon-based life is probably the rule in the universe, not the exception. So if you're an alien, you're probably carbon-based, most likely. I'd say 99.9%. And what are you going to do? You're going to look for planets that have oxygen in their atmosphere. Why? Well, because oxygen likes to dive out of the atmosphere. It wants to bond with stuff like iron compounds, like it did on Mars. We had a lot of water vapor, a lot of water on Mars, but that water ended up being destroyed over time by ultraviolet light. They could penetrate the atmosphere and get down to the ground and start ripping apart H2O, the oxygen of the water molecule. The hydrogen escaped to space and the oxygen dove into the ground, bonded with iron compounds to form a mineral like hematite. And what is hematite? Well, Fe2O3 is an example. That's rust, iron oxide. Okay, so that's why Mars is red. Number one, use that as trivia. So the bottom line is, okay, you have this oxygen, and we stand out like a brilliant, blazing blue beacon in the universe. Okay, we stand out. We're not hiding. Okay, we're not hiding. We can't, because over 2 billion years ago, we started building up oxygen in our atmosphere from cyanobacteria and phytoplankton that started to create oxygen as a waste product from their processes of chewing up carbon dioxide. Okay, so as the oxygen started to fill up our atmosphere, we became visible to the universe as a whole. And if you're an alien species, you're going to do what we're doing. Look for planets that have oxygen. Okay, and that's what we're trying to do. So an alien species from thousands of light years away could already have seen that we have had a huge buildup of oxygen in our atmosphere. And guess what? It's not falling. It's staying constant, relatively constant. Now, the only way that can do that is if it's being replenished, if something is creating it anew. And that's what happens here That's why we're interesting. That's why they'll find us. That's why they can see us. That's why we stand out like a sore thumb to the universe. Okay. And that is why I believe they are here now, because they've had thousands of years to get technology to be able to cross the universal void and find us. And I think they've done it. Okay. Now, I think that kind of answered your question. Maybe.
Yeah, we'll take it. We'll take it. No, that's very interesting. I never thought about it from that perspective. The other big rumor, or I guess that's floating around out there, is that they found signs of artificial light on 6 different planets. Can you go ahead and give us your opinion on that?
Yeah, there's a few stories out there. One of my favorites is that the James Webb Space Telescope has taken a photograph of Proxima b, which is that little tiny planet around the third component of a triple star system, nearest one to us, the Alpha Centauri system. And you have Alpha Centauri A, capital A, Alpha Centauri B, capital B, and Alpha Centauri C, capital C. And around capital C, which is a little tiny red dwarf star, you have a planet, maybe 2, Proxima B and Proxima C. Now, each of these planets could potentially have some type of life on it, B more than C, possibly. But the question is there life? And how would we know? Well, if you're someone that likes to think about those things, you'll say, oh, well, maybe there's life on Proxima b. And then you might say, what would it look like? What would the James Webb see if it actually looked for life? And so people might fabricate photos showing Proxima b with lights on the surface. Okay. And that's precisely what they've done. The James Webb Space Telescope cannot take pictures of individual planets like that. Okay. It can see atmospheres when the star isn't behind the planet and the planet moves in front of the star. As it does so, when the planet's going in front of the star, you'll see the star spectrum. Okay, and that's a very particular set of chemistry in it that you can see in its spectra. And then as a planet passes in front of it, okay, like this planet crosses in front of it, as it goes in front of it, suddenly that star spectrum will have new elements in it. Because if the star's planet has an atmosphere in it, then now that atmosphere is also having the hot, or the hotter gas behind it. Okay, and that will cause the atmospheric molecules to absorb some of that energy, and that will show up in the spectrum of the star. Those are called absorption lines. So the star's planet will have some energy that it'll take out of the star spectrum and insert dark lines into the spectrum. And that will be a signature of what is in the atmosphere. Okay. And when you do that, okay, as the James Webb has done with several planets, you might see the chemistry of the atmosphere that may indicate that there's, say, oxygen in it or other compounds. And that's the limitation of what we can do right now. We can't image the actual planets, not in a meaningful way. We can, we've done, in fact, the Keck telescope, the Gemini telescope on Mauna Kea was able to image with direct light by blocking out the image of the star. They were able to image planets for the first time in human history. Okay. But you can't see the planets as other little specks of light. All right. You can't see them as round balls with surfaces. We don't know what these things, we don't even know if they have atmospheres. But by looking at the pollution in a star's spectrum as a planet crosses, that will tell us what's in there, like the pollution on my finger of white paint from painting my deck. Okay. All right. Like an arrow. It's like an arrow pointing to the top of my finger. That's what the planet is. Okay. But that star's spectrum will be polluted by the tiny atmospheric component coming across it in the planet. That's what we can do. That's what the James Webb did. That's why it found a compound in a planetary atmosphere that looked promising. And if confirmed, it will be almost a certainty that we found life on another world. All right. And there's a compound that you don't even know. We're not talking oxygen. We're talking this weird compound called dimethyl sulfide. What's dimethyl sulfide? You know what dimethyl sulfide is. Everybody listening knows what dimethyl sulfide is, and they just don't know it. Dimethyl sulfide is something we call the smell of the sea. That's a colloquial term for it. But dimethyl sulfide is a compound created with the breakdown of organic life, okay? And dimethyl sulfide is something that you smell every time the tide goes out. Like when you go, oh, what's that? That's dimethyl sulfide, okay? And if you can smell that using a special tool like the James Webb and see that signature of it in a planet going in front of its star, and you see that in the atmosphere, if you found dimethyl sulfide, you found life. Because on our planet, the only thing that creates dimethyl sulfide is life. That's the only thing that creates it. So if we find it, game over. We found life. Okay, that's pretty cool. Now, the interesting thing about that particular planet is it looks like it may be a water world. We don't know for sure, but it means it's fully encased and fully covered in water. And the atmosphere, no, it's not going to be oxygen, nitrogen like ours. It's actually hydrogen. Hydrogen atmosphere. Well, that how can we possibly have life with a hydrogen atmosphere? Well, we don't know all the details now, do we? But if there's a water world, there could be life in the water because water is still H2O with salts in it. And so there could still be ecosystems underwater that will create life forms that don't require the oxygen from above. Now, we know that there's the carbon cycle, there's the water cycle, there's all kinds of stuff like that. So a hydrogen atmosphere is not going to be just hydrogen. There's going to be some carbon dioxide there. There's going to be some H2O water vapor. There'll be some oxygen, but we don't have the full picture yet. But that spectrum I saw shows dimethyl sulfide and a bunch of other elements as well. So, and methane included. So there's going to be tons of stuff that the James Webb can find. What it won't find and won't see is lights on another planet. Every one of those stories, unfortunately, right now is false. And will the time come when we can see them? Absolutely. Is it here yet? Absolutely not.
You brought up a great point about an ocean world. Yeah. Because right here on our Earth, on our planet, deep within our ocean's depths, we have the volcanic vents that sustain life. Yeah, the James Webb is looking at objects distant.
Yep.
Look at our own solar system.
That's right.
Because you could have life in Europa, and you can get more into the details on that, having the same kind of properties that exist here on Earth happening on a moon out there in our own solar system. So we don't have to look so far away to know that there's a possibility, there's a high likelihood that there's life, and not just Europa, but Mars and other moons in our solar system.
Enceladus.
Yes. It's right here, Mark.
Yeah. Actually, there's even theories that there could be aerial life, such as in the upper atmosphere of Venus. Okay. There's a theory that maybe some, I guess, microbial life could exist up there. Because up in those cloud area, up in the upper clouds, they're going to exist with some sulfuric acid clouds, and that's nothing that we can work with. But there are extremophiles. Those are called extremophiles because they live in extreme conditions. Okay. For instance, Lake Vostok is in Antarctica, and it's deep underneath the Antarctic ice. It's been there for millions of years. Okay. Locked in. Well, they sent a probe through all that ice, and they went down into Lake Vostok. And you know what they found? Deep in that ocean? 3,500 different types of life.
Wow.
And cycles, chemical cycles going back and forth, exchanging gases between each other, exchanging different elements between each other to help keep life going along. It's not a stagnant pool of water under there. 3,500 different forms of life, mostly microbial anyway, all in the dark, all using chemosynthetic processes. That is not photosynthesis, not using the energy of the sun. There's no sun down there, okay? And it's frozen down there. The water is under pressure, so it's not frozen at that depth. But think about that. That's an incredible find to know that there's 3,500 different forms of life out of sight, out of mind, deep in the ocean. And there was a recent study that says, and Daryl Mason, my co-host on SkyTour livestream, our observatory livestream, we were live last night. Okay, he mentioned an article that was fascinating, and that was that they discovered the possibility that maybe there's more life underground on our planet than there is in all the forests and all the land and all the water we have on Earth. There might be more life underground. That's incredible. And that's an incredible thought. What it means is the scope of life has been unimaginably narrow. And so we've thought about life as being on the ground, in the air, underwater, not underground. But if we increase that scope, we might find that we have life all throughout all these different biomes on the planet.
And undiscovered species.
Without a doubt, it means there's an undiscovered species. Yeah.
That sounds like the start of the movie The Thing, drilling in Antarctica.
That's right.
And by the way, if anybody wants to experience the smell of the sea, as Mark pointed out, Bill sells a cologne that just absolutely nails it.
I might have a chicken, but that's another story for another time.
It's French. It's called Eau de Stink. Clear the stink.
So that's fascinating thinking about it that way, and that kind of moves me on to the next point. We were talking about USOs, something that Bill brought up. I think it was Lou Elizondo recently said that there's evidence of an underwater craft the size of a city block moving at extreme speeds. Do you think something like that could possibly be in the ocean and have gone undetected so far by most people, Mark?
Well, let's first of all, let's set a scale on the ocean, okay? If the room that everybody's in watching this, okay, look at the floor and look at the ceiling and imagine that's the full ocean depth. And then go like this with your knuckle. This height right here up against the ceiling, that's as far as we can penetrate into the ocean depths with our best submarines in the Navy and so forth. And the ships sit on top. They're at the ceiling. All the rest is unexplorable except by deep ocean submersibles like the Alvin from Woods Hole, like the Murs from Russia, the Nautil in France, okay? Jim Cameron with his deep dive, okay? Those are the only types of vehicles. And what they do is they go straight down. They're elevators. They go to the bottom and they come back up, all right? That's the only thing that can go with people on board to look at this directly. So the ocean is a big unknown. And by the way, this is something that people have trouble seeing and thinking about, because when you go to Google Earth and you look, you see the ocean, all the ocean, you see all the detail on the ocean floor, and people think, hey, we did all that. We mapped all that. Want to bet? We have only mapped, really, truly, 16% of our oceans. Well, wait, Mark, what's all that stuff you see in Google Earth? That's interpreted data from very rapid, very, very coarse surface scans. It's interpreted. It's none of it. It's not real. How do we know? Go to the Malibu Canyon off California. You see the canyon goes down, right? But then you see this vertical drop. And then it just goes horizontal again. In that vertical drop, it looks like there's holes you can go in. Hey, that's a UFO base.
Yeah, pillar
into the wall. There's no wall. It's all going like this. That's an unmapped area. There's a gap in the data from here to here. Okay, so the data goes here, and the data goes here, and there's nothing in between. So when you do the interpretation, it goes, it just goes straight down because there's no data, and then it continues on with the data when it knows. So it knows this data, it knows this data. Okay, it's gonna be more like this. Okay, and so it doesn't know this, so it just interpolates. It goes, zip, makes a vertical line, and continues over. So that it stretches and it makes the wrong thing. And that's what that particular artifact is on Google Earth. It's not a real thing. It's actually a gentle slope all the way down, and it's just that part of it wasn't mapped. It's that simple, you know? So in the oceans, can we have these big? Yeah. I think that the way they operate, okay, I've been lecturing about this very successfully. People love that lecture. In fact, I did this lecture that talks about how they operate in Edinburgh, Texas. And there was a lot of cowboys in the audience, okay? And you don't separate a cowboy from his boots, his gun, and his hat. Okay. At the end of my talk, cowboy comes up to me, takes his hat off his head, and says, "I want you to have this." I go, "What? That's your hat, man. That's like your personality, dude. I can't take your hat." He goes, "No." He says, "You explained the final thing, the final gap is now filled in because you explained how they actually get here from there. From far away, they get here, and how they could exist in the deep ocean without any problems. You explained it. I understood it. And it's such a revelation, I don't know what to do with it. And so the only thing I can do is give you my hat." His hat is here. It's in the other end of the room. If you want to go get it, I'll put it on. But the thing is, okay, this guy understood it. And that's, I guess, if I have a superpower, it's that I can take very, very complex stuff and make it understandable, right? So in terms of how this could happen, right, how we could have, as Toby asked, a giant ship, okay, a big giant ship that can actually exist underwater, it comes down to the methodology by which they move. And that is something that Avi Loeb has just said as well. And it's interesting. I've been talking about it for about 5 years now. It comes from a technique described by Bob Schroeder in his book, Solving the UFO Enigma. He's another guy to get on your show. I think that you would have a good time with him. And Bob's a good friend. And in his book, he talks about diving into the world of string theory. And within string theory, there's a few things within string theory that will help you understand how this can actually work. Now, we're talking about craft that move through the sky so fast that they don't leave a sonic boom. They don't displace the air. What's going on? Okay. And why can they do a 90-degree turn and not like be smashed against the wall and splattered? Okay. Well, they would be. If they were doing a 90-degree turn like that, they would be splattered against the wall. They're very fallible. The only thing standing between them and us is their technology. So if they're going to travel, they need another method. And so imagine a ship that could travel from here to here to here to here. Discrete jumps. Dink, 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 dink. Okay? They didn't travel from here to here going vroom. They went bink, 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 bink. They made 4 discrete jumps. Okay? You're in the ship, in the UFO. All you see is that destination getting closer, 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 and closer again. You don't see vroom. You just see dink, 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 dink. Okay? You're popping out of the 4 dimensions that we're in and popping into the next location, popping out of the 4 dimensions we're in, popping into the next location. You leave our 4 dimensions and you travel into a 5th dimension that's well defined by this string theory called Randall-Sundrum 1, RS1. RS1 allows for this 5th dimension. You have 4, X, Y, and Z moving through time. Okay, at this position in time, X, Y, and Z coordinate can be fully defined. At this position in time, the X, Y, and Z coordinate can be fully defined. So it's all about moving through time and defining our X, Y, and Z coordinates, which define our exact position in our space. Okay, great. But what if you can leave those 4 dimensions, okay, pop into a 5th dimension where those 4 dimensions don't exist, and therefore the rules of our universe don't exist, okay? You would find that the farther in you go in this 5th dimension, under Randall-Sundrum 1 now, okay, that would cause you to be in an ever compressed universe. The farther in you go, the smaller the universe is around you. The farther in you go. So here on Earth, and I'll explain what that means, okay, if we travel 12 inches in our 4 dimensions, we go from here to here. 12 inches. There we go, 12 inches. Ding, ding. Okay, that's it. But if we go from this location and we travel into the 5th dimension and go in just a tiny little bit and travel 12 inches within there, when we come out, we might have traveled 22 inches because it's compressed. The universe is compressed. That same 12 inches gets us more distance when we come out because it's compressed around you. Let's say you go really far in and you travel 12 inches. When you come out, you might find yourself at Pluto. So if you can actually go into that fifth dimension, which has a specific name, it's called the bulk, like bulk produce, BOLK. Okay, if you can travel into this bulk, the farther in you go, the smaller the universe becomes around you. Okay, and when you come out, you will have traversed whatever distance you travel in there. Okay, a small distance in there translates to a large distance out here. So this is how they do it. So when they're in, I'm guaranteed, I'm convinced of this. So if they're flying through the air, you watch this thing fly through the air, make a 90-degree turn. You go, whoa, nobody could survive that. And you're right. As I said, not even them. But what they're doing is they're popping out of our 4 dimensions up here, and they're going into this 5th dimension, this bulk, and then popping in at this next entry point, going up, popping back into this next entry point, and doing that over and over and over. So when the 90-degree turn comes in, all they're doing is going like from, say, here to here to here, and then to there. Okay? So to them, they didn't make a 90-degree turn. If you're in their ship looking out their windows, all you'd see is the scenery changing around you. You wouldn't feel any forces on you whatsoever because you don't generate any. So they don't even need engines. They don't have engines. They don't have thrusters, nothing like that. They're just generating particles that take them into this 5th dimension. And those particles are well known. They're called Kaluza-Klein particles, KK particles. And because they're very powerful, they are like 10 to the 16th times more powerful than the particles holding you to your chair, if we believe in gravitational particles, gravitons. We haven't found gravitons yet, right? Light, we can talk about light as a wave. We can talk about light as a photon, a particle. We talk about the electron as a particle. We can also talk about it as an equation, okay? And we can generate a wave equation to define a proton. So we have this duality, particle and wave, right? We have wave nature, particle nature. With every single fundamental force we know, we can define those things in that way. Get to gravity. We don't really know much about gravity. We know that gravity sucks. Okay. But, when things fall, they fall because of gravity. Okay. We can calculate the value. Yep. Okay. That's easy. We can calculate the force. That's easy, of gravity. But can we manipulate it? Well, we can bend light with a lens. We can reflect light with a mirror. We can change the direction of charged particles with magnetic fields. But what about gravity? Well, Einstein predicted we may never see gravitational waves, but we did. 2 black holes colliding, boom, caused ripples in space and time that caused ripples seen throughout the universe, which came to our planet, passed right through our planet, detected by 3 detectors on our planet. So now we know when neutron stars collide, very, very powerful gravitational centers each, they generate these ripples. When black holes collide, they generate bigger ripples and boom, boom, boom. And so now we've seen gravitational waves. We just haven't seen gravitational particles. That's the next thing. The graviton is elusive. And if the Kaluza-Klein graviton exists, then what we do is we use that technology of the Kaluza-Klein graviton being 10 to the 16th times more powerful than our own to pull us into this 5th dimension we've been talking about up here. Because that's why we don't see gravity. The other end of gravity, when light starts and stops, it starts and stops in our 4 dimensions. An electron moves in our 4 dimensions. It goes out and back, okay, in our 4 dimensions. Okay, vibration of particles happens in our 4 dimensions. One end to the other, it's inside. In string concept, that means the loop completes itself within our universe, within our 4 dimensions. In string theory world, that's how we think about it. Now, if we talk about gravity, it starts here. That's why we can calculate its force and calculate its effect on our ships and calculate gravitational whips and utilize it. But it's why we also, most likely, is why we can't see it. Okay, why we can't actually call it a particle. Because the other end of gravity is out in this 5th dimension. So if it's in there, that means that we have to generate a methodology to get in there. So we generate particles that have the other half of themselves living there effectively. And so that means that if we generate the particle, go into this 5th dimension, now we're using gravity to do the work. Okay. So, I know it's a lot, but what you have to understand is that if this Kaluza-Klein gravitational particle, the graviton, exists, then we know that we can utilize it for something special. I'll explain how that works in a second. But you might think no one's doing any research into this. The Kaluza-Klein graviton was theorized back in the 20s and 30s. Okay. And CERN overseas, the Large Hadron Collider, when you speed up protons and send them around the ring very fast, the ring is 22 miles in diameter or so, I think, or around. Okay. When you do that, you collide them, and then you have detectors that detect different things. So you get this splash appearing on this detector, this one, boom, 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 all the way around. Well, they made a new detector called the Atlas detector. And Atlas, a very successful program, was used in part to detect Kaluza-Klein gravitons. And they were found. The Kaluza-Klein particle results were really kind of interesting. So CERN is working on the Kaluza-Klein question as well. Now, on the other end, you'll say, well, wait a minute, you gotta generate those particles. What do you mean? You got these giant accelerators, you gotta collide particles, and I mean, how many can you get? Well, you gotta surround your ship with them on an ongoing basis. So we're not there yet. We're not at that technological capability. But what we are at is the ability to see that they may exist. Okay. So we need a gigantic ring to generate a small number and detect a few detections. Being a couple thousand years even ahead of us, they would have figured out how to take that giant ring and put it in a small UFO, a flying saucer shape. Why is it round? It's a particle accelerator. It's generating particles, right? And it surrounds itself with these Kaluza-Klein gravitons, moves into the fifth dimension. All you need is an accelerator in your ship. And when you do that, there's certain detrimental effects that would happen to humans if you're around a ship that's doing that. And guess what? We've seen that in the history, in the literature. People say, I touched this UFO and I got burned. Yeah, you did. And the reason is because if you're going in a circle with particles that are charged, to keep them going in a circle, you need intense magnetic fields. Okay, you got to curve those charged particles around. Otherwise, you're just going to go bam into the wall and scatter, and that's the end of it. If you want to keep them in a tube going circular, you got to have magnets, very powerful magnets, directing them around and making that circle. If you make that circle, well, that generates something else that's not good. It's called synchrotron radiation. Synchrotron radiation, and when you're forcing something around, a charged particle around in a circle, synchrotron radiation is trying to go out on every other side. Okay? Very dangerous to us. Okay? So if you have a ship, you shield the center core, okay? And on the outside, you have the outer ring where you're generating these particles. You're safe as long as you're in there. Mm-hmm. That's where you go. Ow.
You know, okay? Mark, I don't mean to interrupt because we can do like a mini series with you of 4 shows with all the information and we had about 10, 15 minutes left, but that could explain a lot of sightings that people say where they see something appear and then it seems to vanish.
Yeah.
Goes into cloak because it's entering that fifth dimension. So it's at that one place at that one time and it seems to vanish because it's going into that next dimension.
That's right.
But I wanted to touch on something. Supposedly they're going to be focusing on USOs November 13th when they have this hearing.
And what? Oh, the next Congress?
Yeah.
Yes.
So Gallaudet, Rear Admiral, retired.
Tim, yep.
Yep. But you were also associated with him in a project that Darcy with the Transmedium.
Transmedium, yeah. Tim Gallaudet and I did that with Darcy, yeah.
My first question, did you ever at that time have a direct interaction with Gallaudet on this because of your personal experience observing a naval officer reporting something on sonar, a fast mover while you were on that nuclear submarine? And to finish that, I know it's loaded, would you, if called upon, be a witness at a hearing and testify about your experience on that submarine?
Absolutely. And the thing is, Tim Gallaudet, I know Tim after the fact. After he did Transmedium, we met, we've talked. Okay. Tim is great. We also have Bob McGuire, who was on the USS Hampton. I was not allowed to name the sub I was on at the time, but Bob did. He named the USS Hampton. I don't know if he was supposed to, and they had an object zipped by them at hundreds of knots as well, just like on this boat I was on. So that wouldn't be a problem. I would do that. But the thing that's interesting, okay, is that Tim, listened to my story, and I mean, I tell it like I remember it. And he came away saying, I think to Martin Willis on his show at the time, he came away saying, everything he's saying, he had to have been there. So in other words, people that say, well, it's all baloney, blah, 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 they say he had to have been there because some of the details he said he can't make up. It takes the knowledge of what's going on and seeing to understand what's really happening. So he's seen it. So, I mean, I'm aware that people doubt the story, but there's no reason to doubt it. Science supports it. The science supports it fully. And that's the thing that really bothers me. And I fight the arrogance in science too, where people don't believe they're here and all that stuff. It's like, you got to understand, they've known we're here for 2 billion years because we've been sending out that oxygen signal to the universe for all that time. So you don't think that an advanced civilization made of carbon that uses the oxygen is just going to say, oh, another oxygen world, let's move on. No, they're going to say, if they're explorers, if they're curious, like every creature on Earth, by the way, it's a characteristic built into their nature. They're curious. It's a characteristic often overlooked. And that curiosity leads you to ask questions. What's that? What's that? What's that? Let's go look at that. Yes, it gets people in trouble and killed. Okay. But that curious nature of humans, dogs, cats, all creatures on this planet, even small microbes, have demonstrated the potential for being curious as an evolutionary trait. That curiosity is probably baked into life in the universe. Maybe. And so that means that if you have a species that sees oxygen, they might say, what's that? Let's go see. Next thing you know, you're visited. We've had accounts for thousands of years of visitation since history started being written. So are they all wrong? I mean, there's an outside chance they're all wrong. But if they travel using this interdimensional technology that I've been talking about, let me give you an example of how quick they can get here. Let's suppose Proxima b does have a population on it. It probably doesn't, but you never know. I'm holding out hope. I'll explain something else about that too with Las Cumbres observatories. And let's suppose there is a civilization there. And let's suppose they've done the work to create this fifth dimensional transitioning technology I talked to you about. From there to here, believe it or not, using this technology is a 20-minute ride. Okay. Sounds fantastical. You say, well, they can't go faster than light. That is exactly right. And they don't. In the 4 dimensions, they're constrained to light speed. When you go into the 5th dimension, you don't have a constraint because you're not actually traveling. You go in, you move the distance within there that you're going to move. And then when you come out, that translates to a much larger distance when you come out, way larger. So you're way, way, way larger. So you're at a farther distance. So you can actually work it out so that you can get here in just maybe a few of those transitions, a few of those pops. You know what I mean? And it depends how far into the bulk, the 5th dimension, your technology allows you to go. If you can go way far in, then you can get here quicker. If it takes you longer, well, it might take you a day or two, or maybe 10 hours to get here. Okay. But still, you can get here in a lot less than the 10 to 12,000 years it would take with our current technology of chemical rockets.
Huh.
Oh, and
that makes me
talk about, I was going to talk about Las Cumbres and life on Proxima b. Skytour Livestream, our remote observatories, has been named in a award for doing a research with world-renowned Las Cumbres Observatory. And what we're going to do is we're going to be looking for exoplanets around Proxima, and we're going to see if there's some that went unnoticed. We're also going to look at Barnard's star, a very fast-moving star in our neighborhood. It's a really, really small star, one of these red dwarfs. And we're also going to look at a big red giant called Mu Cephei, or the Garnet star. Okay, Herschel's Garnet star. And we're going to see if a planet could have survived its massive supergiant red giant stage. And we're going to look for that too. So this line of research is something that we're really eager to check out. All right. So it's all about exoplanets for me. That's my specialty in astronomy as an astronomer. But I think that they can be here. Now, as a little caveat, and I'll sorry about interrupting you there, Toby. Okay. That's him right there. See him? Ding, 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 ding. Okay. No, but as a caveat, I want to add this finally to all of this. This isn't just me or Bob Schroeder or some of the other physicists out there that have talked about it, or astronomers talking about this particle transition. This is Avi Loeb too, because he just came out and said he thinks that maybe they travel interdimensionally. Kind of makes you think, doesn't it? Now, the energy created that you want to create in your ring that we talked about in your UFO that generates the particles, how do you generate that kind of stuff? It's an accelerator. Okay, great, Mark. How do they actually power it? Well, they can't power it with like the same technology they use here. I mean, they stir up, 1.2 gigawatts of, 1.21 gigawatts of electricity, Marty. Okay, they can't generate that kind of power, right, on a little UFO. So how do they do it? You need something. You need a reactor. Okay, great. Now, they can use a fission reactor like we have on our planet that can melt down. No, they're going to use a fusion reactor.
What about the sun as a source?
Well, they are effectively, because they're going to create a fusion reactor. In the core of that ship is a fusion reactor. It's going to power this ring. And guess what? Out at Lawrence Livermore Laboratory, in the last year or two, they actually did a really cool, groundbreaking, history-making test of fusion, where they actually, instead of just fusing one bit of material inside of a magnetic bottle that they did, it's like, tink, and it's done. Yay, we did it. Yes, they got fusion to work. What they did was they did it, and it kept going. They were able to keep it going. That's called a sustained reaction. Now, they didn't get more energy out than they're supposed to get, because we're putting way more energy in than we get out right now. The break-even point is where we break even and just get as much out as we put in. We want more out than we put in, like the sun does. Okay, so we have to work on technology to do this in a more effective way. That said, they, at Lawrence Livermore, created a sustained fusion reaction. What's it mean for all of us? And what's it mean for everything I'm talking about? It means that very soon, eventually, I should say, we're going to have a stable fusion reactor system that we'll be able to use to power a ring in a little ship that will generate particles that will take us to the other end of gravity in this fifth dimension and allow us to hopscotch across the universe.
Wow.
We are very close, figuratively as a species in terms of the universal time, from being able to hopscotch across the universe and say hello to the extraterrestrial brothers that are here now.
Well, I volunteer Bill to be the first person to ride in that ship when we get it going.
Me too.
And no, I was just going to say with the talking about the different dimensions, I watched a video previously. I think it was called Carl Sagan's Flatland Animated.
Oh, yeah.
And it gave me a pretty good explanation, of how different dimensions operate and how people would see things in different dimensions. So
right.
Taking that and then hearing you actually describe how you would go into this fifth dimension and everything, it's fascinating. But like Bill said, that would make a lot of sense. I mean, if these things were moving, could that be part of the reason why they appear distorted to us too? Is that they're going in and out of another dimension?
That's a very astute observation, Toby, and let me explain why. Now, as an astronomer, we can describe things that look distorted as, atmospheric turbulence. We can describe things that look like they're moving from one position to another when people are observing them in the sky. We can call that the autokinetic effect, with your eyes are not able to focus on one spot. And all these things are true. We can see them changing color, and then they seem to vanish and come back, and they change color. That changing color, we can call that atmospheric scintillation, where things change color because, the light is being disrupted a little bit. some of the blue light is taken, and so the red comes through for a moment. Oh, we see a red flash, and then we see a blue flash, and so forth. All those things could be true, but as Avi Loebitz says about Oumuamua, we can't ignore the possibility that we're looking at gravitons, Kaluza-Klein gravitons, that are causing a ship to pop from here to here to here to here, and thus changing positions in the sky instantly. We can't ignore the possibility that the Kaluza-Klein gravitons are distorting the light that are coming to us from a UFO, causing it to look like it's changing colors, right? We can't ignore the possibility that the Kaluza-Klein gravitons are also, causing other factors to occur on this ship, all right? So, for instance, when we talk about it vanishing and reappearing, yes, okay. Fading in and out, that could be the ship as it's fading out of our dimension to go into the fifth, okay? Now, in order to live in the deep ocean, we didn't touch on this, how would a craft doing that be able to do it? And we couldn't talk about it until we talked about the fusion reactor, okay? When it's down on the water, okay, it's shifting back and forth, I believe, into the fifth dimension and then back into our four, okay? It's doing this faster than we can even see. It's doing it at a high frequency. So technically, it's not here and it's not there for any appreciable period of time. It's not underwater, under the high pressure of the water, and it's not in the bulk, fifth dimension, for any period of time. It's constantly transitioning. So there's no time for water to go boom, and do to it what it did to the Titan. Okay? There's no time for it to do that. And when it's in the bulk, in the fifth dimension, it's actually just goes in, stays, and comes back, and they oscillate. This oscillation is crucial, because if they oscillate back and forth like this, see how my hand's all blurry? Okay? If it stops and you can see it for any period of time, it's going to go, So obviously, they won't get crushed, but it's always in a blur, so it's never quite there. And that's the reason, I think, why they look the way they do. That's why they change color the way they do. That's why they can disappear from here and appear here like they do. So everything that people have reported for hundreds of years about UFOs could be explained by the use of Kaluza-Klein gravitons.
Even TikTok, it seemed to be TikTok was doing some kind of movement on the water surface. But we only got a minute left, Mark. So let everybody know where they can catch you, support you, contact you, all that good stuff.
Well, you can find us at the SkyTour live stream. We have a Patreon, and we talk about these things on our live observatory streams. And we were doing yesterday, we talked about some of this stuff, dimensional travel stuff. And meanwhile, that's SkyTour live stream. That's at skytourlive.org. Okay, we are a nonprofit organization. And I don't make any money on it. I'm actually not taking any pay for this. I'm doing it because it's passionate. But we could appreciate the passion. I'm MUFON's chief photo and video analyst. I'll be teaching out at the Phoenix MUFON Boot Camp the second weekend in November, on the 8th, roughly. And I'll be in Arizona from the 30th to the 12th of November, 30th of October, 12th. And I'll be out there working on the observatory we currently have in the Sonoran Desert, and then looking at the new site, and then heading to do the Phoenix Boot Camp. So we're looking good. So you can find me there, skytourlive.org. And so we would appreciate any support we can get. If you want to hear more of this stuff.
I do. I do
too. Mark, thanks so much for joining Toby and I today for this show.
Been a pleasure, Mark.
All right. Thank you, guys. That's Mark with a C, Toby.
Yeah, to do the shades. All right, everybody. We're out of time for this week. We'll have Mark on again soon. For me and Bill, thanks for tuning in, and we'll see you guys next Monday.
Run.